So welcome to this EUMeTrain ePort weather briefing today. It seems like I will be now conducting this weather briefing. I am Alessandro Chiariello from the Finnish Meteorological Institute. And also I have the pleasure to inform you that Andreas Wirth from the Austrian Met Service from ZAMG will be presenting an interesting study case about heavy snowfall in southern Austria, which occurred, I think, a few days ago. Okay, hopefully you can hear me well. So how I look like? I am this guy here in the left-hand side of the screen. And well, I'm Italian, but I've been living several years in Finland, almost half of my life, 17 years in Finland already. This is my family here, that's why I'm living in Finland. My wife is Finnish, and so I have 3 kids. And yes, what I'm doing, what is my job, currently my working time is split between EUMeTCAL. I'm a training support officer of EUMeTCAL. I hope that you know what it is. EUMeTCAL is the virtual training organization for meteorology in Europe. And also I am coordinating a development cooperation project between the Finland and Sudan and South Sudan. So this is 50-50 for the moment. Let's move ahead. So now we want to know a little bit what is your link to meteorology, why you're here. So please use the markup and indicate what is your main duty in your institution or life, whatever. So it's interesting. So there are many forecasters. So I will need the help of forecasters in this briefing. Okay, so there are also some trainers, interesting, researcher, and other. I don't ask who are these others, but interesting to know. Maybe you can write it in the text chat box. Interesting, guys. Okay, thank you very much. So now there are 12 people, excluded the presenters. Software developer. Okay, interesting. Okay, nice to see you are very active and you can use this tool. Okay, and again, I'm engaging you again. If you can point in the screen where you come from. I'm sorry that this map is not the best. I mean to discriminate the stars, but this is the actual weather map from yesterday at about 5 UTC. Okay, I see that some people are coming from Baltic countries, then from Edinburgh, Spain, Portugal, Northern Spain, and Central Europe, East Krakow, and Italy. Okay, that's I forgot to put my own star. I'm from here. I'm from Helsinki. Okay, that's great. Okay, I think that at this point Andreas can take you can step in on the floor and start your study case. Okay.
Thank you, Alessandro. Welcome to this morning session from my side. My name is Andreas Wirth, and I have prepared a very interesting case which happened in the end of January and beginning of February. It lasted from Thursday to Sunday, so over the weekend, and it was a really exceptional case. In Austria we have a lot of snow in the winter times in the mountains, but we didn't have that much snow in the last years as it occurred in this time period. So I will now go to the weather situation. What was the origin of this weather situation? How did it come that so much moist air was driven towards Austria, towards the Alps, and the precipitation was that high? I have prepared a loop. I can show it to you by clicking on the next slide. And I hope it works for everyone. At least I can see it already. Can you click yes if you see the loop? So most of you see the loop, fine. I tried to keep it small. Let me comment it in a few words. What you can see here is that a low pressure area which originates from the British Isles is coming towards the south over France and then reaches the Mediterranean Sea, the sea south of France, and then turns turns right and moves again towards the north. And this is the situation which caused that much precipitation over Italy, over northern Italy, and also over Austria. So the low pressure came from the northern area and was filling up with moist air and was directing then this moist air from the Mediterranean region towards the north. This is a very typical and common situation which often brings a lot of precipitation to the northern regions of Europe, to Austria, and is very welcome by skiers because then they have a lot of snow for their winter sport. I don't know, I have skipped a slide, sorry, I wanted to show this one. Here you see the system on the day before the precipitation event. I will contour it with my pen. And you see, I will click now with my laser pointer here, kind of warm front, a cold front, and an occlusion, a very classical system which occurs several times during the winter. So, and I would like to ask you now, from your personal experience, put a yellow star on the region where you expect the heaviest precipitations, just within this black line. So where do you guess will we have, on this image here, the maximum precipitation areas? Okay, thank you. Yes, no comment, you're perfect. Yes, wonderful. I think you have seen the case before. Okay. I will give you the solution to this question later. We will come back to the precipitation analysis. There is another interesting phenomena which often occurs together with this typical weather situation. You have here the same image, the infrared image, and now we have also superimposed the mean sea level pressure. And there is something very interesting you can notice over the Alps. You have this kind of nose. We call it in German, I tried to translate it to English, Föhn noise. So it's something like that, which happens to the isobars in the region of the Alps. Why do we have this Föhn nose? Not noise, so nose, sorry, like the nose in the figure. Föhn nose. We have here an area of higher precipitation south of the Alps and an area of a little bit lower precipitation north of the Alps. And this is due to the streaming of the air over and around the Alps. But this is a typical pattern you can always observe when you have the so-called Föhn phenomena in Austria, and surely over other mountains is the same effect visible. But here in this isolines with the mean sea level pressure, it's a very classical and a nice feature you can often see in this kind of weather situation. Very interesting is also the precipitation. I superimposed here the synops, and you see, now we come to the answering of your question. You see that here in this area, that's the area where you pointed the precipitation maximum. You see here the precipitation, sorry, not exactly, maybe a little bit like this here. precipitation is mainly in liquid form. So over Italy and Corsica, Sardinia, over the Mediterranean Sea, we have heavy precipitation, but in liquid form. While in the northern part, I erased this here, the northern part, Austria, northern Italy, and Slovenia was also particularly affected by this event. You see that the precipitation is in kind of snow, and we will later see the reasons for that. This here is, let's stay with the precipitation analysis, a product of the nowcasting SAF. This is the convective precipitation rate. It's a product designed for summer weather situations when you have convective cells around. And here I superimposed this product to the air mass RGB. By the way, you can see here the nice red area of the downward directed dry air streams, and in white-greenish areas the high clouds. But you also see in colors, and we reach here very high amounts of precipitation. The scale is in millimeter per hours. I did not show you here the scale because it is scaled for summer precipitation events for convective situations, but nevertheless, and that was visible also in your analysis, we have here two precipitation maxima which are clearly visible in the precipitation analysis from satellite images. But again, this product here is tuned for summer precipitation events, but it shows here for a February situation very nice values which correspond to reality. So it's a nice surprise. The product is not designed for this kind of situation. So then I also wanted to show you a vertical cross-section. This, what you can see here are the Alps. Here, sorry, I have to put a star. And then the vertical cross-section starts somewhere over Greece. So the most right-hand part is Greece. You have dry air, but it's not so interesting. But nevertheless, the cross-section from the ePort crosses the Alps, and you see here again very high values of humidity, upgliding air, and this is the origin for the precipitation we have seen in the charts over northern Italy, over Slovenia, and the southern part of Austria, which was very heavily affected by that event. Then I have also here a radar image, and you know that radar with snow is a little bit difficult. There are some problems because of the ice crystals. Precipitation is often underestimated because of the nature of the ice crystals. Weather radar best works with liquid water droplets, but nevertheless, you see here the precipitation maximum at midnight in the night from the 30 to 31 January. As I can remember, it was from Thursday to Friday in the night. Then the precipitations started in the southern part of Austria. There were high alerts. Our weather service warned for high precipitation amounts, and unfortunately, at this time, the school holiday just started on the weekend, and many people from the eastern part of Austria come to the southern and western parts to go for skiing, and there were heavily traffic jams expected. And in fact, the situation was not that wild because the warning arrived in time a few days before, so the people could delay or get earlier to the places. Now let's come back to the question: why did we have fluid precipitations or liquid water in the southern part and snow in the northern part? In the southern part of Austria and in the central part of Europe. So you see here the zero line of the temperature at 2 meters height, and this is the location of it along it crosses northern Italy, it goes through Slovenia, yeah, and you see that the southern part of Austria is located in temperatures below zero. This is the 2-meter temperature, while Italy here is still in positive temperatures. That's why we had a split situation, snow in the north and fluid precipitation, liquid precipitation in the south. Again here we have the so-called Föhn nose, and I plotted a red line which shows exactly where the clouds stop. Because this is also a very typical phenomenon for Föhn. The clouds are located, when you have the current from the south, the clouds are located on the southern part of the Alps. The upstream, the rising of the air, and the falling of the air mass on the northern part of the Alps here creates the so-called Föhn window, and that's something we can see here very nicely. So we have snow precipitation here and no precipitation 100 kilometers to the north, where you have no clouds, warm temperatures. I remember that on that day we had slightly minus temperatures in the south and temperatures around reaching 10 degrees plus in the north because of this typical Föhn situation. This is an excerpt from the from the Inca model, and it shows you nicely what I have just mentioned before, that the precipitation stops exactly at the Alpenhauptkamm, there where you have the mountain crests. So this is very nicely reflected in the model fields. Precipitation in the southern part and no precipitation in the northern part. And during these days with the heavy precipitation, we made this Inca analysis and Inca forecast fields available for the broad public. And normally they have to be paid. You have to pay to view that on our page. But for these few days, they were made available for free, so that people could see the present situation. Well, and hand in hand with heavy precipitation goes also the danger with avalanches. And in Austria we have an avalanche scale of 5 scales, from 1, sorry it's in German, but 1 is very small risk of avalanches, to 5 very high risk of avalanches. And this is the situation, the plot, from, I think it's the 31 of January. And you see that after the heavy precipitations, snowfall, you see that we had the warning was issued 4, which means very high risk of avalanches, and any skiing apart from the secured areas or walking in the mountains should be avoided. 1 or 2 days later, this level was increased to 5, and 5 is the highest avalanche warning scale. This means that avalanches can go downhills without the interaction of any human. They get loose from themselves, and you never know when this happens. So we had warnings of avalanches. Situation was very dangerous during this situation of heavy precipitation. And there was also snowdrift, which also, I have written it here, which also increases the amount of snow in some areas, and this favors the avalanches in some parts of the mountains. Well, here are some impressions of the snow amounts. I mean, I would have liked to be there. It's really nice. Unfortunately, in Vienna we had no snow, or only 3 or 2 centimeters. So this is something, if you like snow, this is a very nice situation. There were problems with snow load on roofs. You can imagine, if you see this photo, that the weight of that snow on the roofs can reach several tons, especially when it starts to rain. And that's what happened in the coming days. On Saturday and Sunday the temperatures were rising, and it started to rain, and the snow was absorbing all the precipitation, and these roofs were loaded with a lot of snow and wet snow, and even that the roofs are built to support this kind of weight, they were sometimes above the limits which they were designed for. Here is just a few, and this is already my last slide, just a summary of the snow depth. We have in southern parts of Austria, but I can tell it again, Slovenia was also affected, and northern part of Italy the same. But I have only the measurements here for the southern part of Austria. We have from 110 in Lienz, this is the quite a big city in the southern part of Austria, to 150 centimeters in Croatia Mountain. This amount of snow corresponds to an annuality of 75 to 100 years. That means only once in a lifetime you happen to see that amount of snow if you are living in that region. And again, I would have liked to see it, but unfortunately I was in Vienna and could see only the photos, but it's really an extreme situation, and luckily there were no big incidents, also due to the warnings some issued days before. So what I already said is that on the 2 consecutive days there was some rain mixing to the snowfall, which increased the snow load on the roofs. Then the trees were breaking because of the snow load, and trees were falling on railroad connections. This was a problem at the time. Bringing all the tourists to their destination, this was sometimes impossible for days. And also the roads were closed because of avalanche risk and because of trees. And this is also a problem. This was a problem for several days. Trees were falling on the electric cables and breaking them, so there were no electric current for some regions in the southern part of Austria, and it even affected more Slovenia. They were also affected by broken electric lines. So, and my last sentence, and then I give it back to Alessandro. For East Tyrol and Carinthia, these were the highest precipitation rates measured since 1917. That's quite impressive, and I think we will have to wait a long time to have such an event again. Thank you very much for listening.
Okay, thank you very much, Andreas. It was, as you said in the beginning, it was a very interesting case. So let's go now back to the weather briefing. This is the weather situation, actual weather yesterday at 4 or 5 UTC from the Italian Met Institute. And again, since there are new people joined, please, again, put your star and show me where are you from. Very, very quickly. If you can just see that we got other people, new people from somewhere else. Okay, they are mostly from the places Central Eastern Europe. Okay. Oh, there is somebody else also from Cyprus. Wow, that's interesting. Yeah, great. So it's okay. So this is the weather map with usually people, normal people, not meteorologists, get in their hands, maybe in the bus, in the newspapers, and on the TV, and so on. Sometimes I like to see. We meteorologists, somehow we can read this map in a different way. So just to very quick overview, so we can see that from this map yesterday at 4 p.m. UTC, we can see that there are some rains here, rain areas over the British Islands. Then there are some other rains here over Eastern Europe, so we can see this strip here. It's kind of stripped, so we will see later why that. Then in the Eastern Europe here, it's kind of a bit mist and foggy, so maybe already we can have some insight that maybe this is kind of warm air mass, and this might be the So where this rain, maybe here the frontal band between the warm and cold air masses. Then there is a sunny region in the middle here, Central Europe, Southern France, Spain, and so on. Okay, and then we have some rain then in the upper there in the Iceland, and so on. Okay, let's go ahead. Okay, this is a water vapor image that's from channel 6.2. I've never liked water vapor images. I used to be a forecaster many years ago, and they're, in my opinion, very difficult to maybe to interpret. But so water vapor tells us, water vapor images, especially this 6.2, tells us about the moisture content in the middle and upper troposphere, and also it can be used to identify, to locate the jet streams, jet streaks also. So, and also to discriminate between locate also the different air masses, warm and cold air masses. So what I'm asking you now, so now we can just have a bit of interaction to maybe using the star. I don't think that maybe drawing the line may be a bit messy, but with the star, if you can locate where is, in your opinion, where are located the jet streaks in this picture, which is yesterday at 12 UTC. Okay, I see so many people are agree on that one. I see. Oh, interesting. Yes. Oh, they are very interesting things. Somebody also is very okay. I see very nicely. Yes, I agree. It's also interesting. This somebody put here. This is very interesting, in my opinion. Yes, something here. Okay, very nicely, very nicely. Yeah. So you are. I see that there are also many forecasters here. So you're much better than I am, than I would have been. Of course, I know now the answer somehow. Yes, very nicely. And also, what about in this picture? You can see also that the air masses. You can see that quite nicely. It seems to me, at least, that let me. So kind of this is kind of border between a warm and cold air mass. Then it seems like here in the central part of the Mediterranean, kind of as the cold air mass has been falling down into southward, and also here maybe another. I can see here kind of another air mass division between the warm mid-latitude air mass and the polar air mass. But okay, this is something. Okay, thank you very much. Let's move to the following slide, and okay. So this is the same water vapor image, but with superimposed the isotouches at the 300 hectopascals level. Again, it's yesterday 12 UTC. So I think that, as most of you were right, there is here just streak here, one very nicely, and then there is also some of you was putting here. I wouldn't have looked at there, so I'm very happy that many of you did it. So something is also here, and so there is not so clearly visible, but something should be also the case down here. And yes, then I was thinking about because this is the numerical model superimposed with the water vapor image. I was thinking whether the jet streak here is a bit further south, too much south than it is in it was in the reality. But also when we consider that this is just at 300 level, 300 hectopascal level, so maybe it was a bit higher, the jet stream, maybe the location, the matching is not not ideal in this case. And also look at here, also there is a jet track here and something happening down there. We will see later why it is important, what is happening here. Okay, thank you very much. If you have any comment, if you want to share with other people some comments, also feel free to write in the text chat box. Let's go on, and this is instead something I like. I've always liked, maybe because it's more colorful. It's an RGB air mass composite. From here you can discriminate. Yes, you can discriminate the different air masses. And again, yes, I need your help. I've been so far away from the forecasting desk that I need your help to identify the different air masses that you can see here. So where can you see the warm air mass? Yes, so some people are putting there. I think it's clear that they use this greenish. Usually these greenish colors are identifying warm air masses. Yes. Yes, it's clear that our air masses are more or less there. And what about so stop it and now, and you see also that the cold air mass are on the other side, and you can easily see that there is this the cold air, polar air, has been flowing southward into the central Mediterranean. Yes, thank you. Very nice drawing. And also, what I like to see this, what I like to point out this this kind of these occlusions, indicating that the warm air mass is somehow penetrating into the cold mass. So we can see one here very nicely, another here. So the warm air mass is penetrating into the polar mass. And also we have some, also these are very old occlusions, maybe, at least this is an occlusion, but in my opinion also this is an occlusion, but this is old pool of warm air, which have now been lifted, and they are there. Okay, let's again go forward and see the same image, but this time with the numerical field superimposed. So here we see the fields in the middle troposphere, jet potential height and temperature. And as you see, also this allows us to, I would say that maybe in my opinion, so the border between considering the temperature at this level, so the warm air mass a little bit, it's a bit there. The border between the different air masses. Then something here, it seems to be in this side, another border, and then also we have something down here. Yes, another border between. So there is the border between the polar air mass and the warmer air mass, and also very nice to see this intrusion of, I call it intrusion of warm air. So in this occlusion here, so we see something here also. I hope you can see. Maybe I use the star, it's better. And also something here. It seems like warm air is coming inside. And you see also from the kind of warm air nose up here. So there is a kind of very not very well defined, but there is some kind of warm air there which has been lifted up. Now is mixed with the environment, so not very. Okay, so I hope that you agree with me. on this distinction between different air masses. Let's move away. If you have any comment. Yes. By the way, there is an error here. This is not. This is an error here. So this is the infrared image with superimposed the thickness, and in the upper middle troposphere. So I like the thickness also because, at least when I was a forecaster, I used to use it to identify. Thank you, Ivan, I guess. To identify the frontal bands. So we can really see that very nicely, the frontal band. So again, considering the border between the two different air masses, one frontal band here, another very clearly here down. Then we can see something down here. Another frontal band. Then what else? And then again, these warm air intrusions here, also these occlusions and something here. So can you identify other frontal bands, frontal border between different air masses? Feel free to point in the map if you like. Okay, thank you very much. So you all agree with me. So please answer yes or no. It's nice to see people reacting. Yes. So we are somehow. Oh yes, very nice. That's came in. Yes, a warm front. Yes, that's correct. I like this. So there is somebody was very brave and put here another very nice form. That's a warm front. Yes, excellent. Very, very nice to see that people are active. And I think also there is something there up in Russia, but no, I don't know what is there. Frontal band also there. So we are now. So you see what we're doing now. We are a little bit with the help of satellite images and numerical models. We are a little bit trying to identify these synoptic scale features. By the way, I walked into the forecasting office here in Helsinki a few days ago, where I used to be many years ago, and I saw the two forecasters. They were staring at the numerical models, and the radar picture and so on. They were together. There was the aviation forecaster and another general forecaster. They were discussing, trying to understand what in Finland what was causing this rain, because the numerical model was giving rain from some days upfront, but they did not understand why it was caused, from where it came, this rain. So this made me think that how important it is to understand the atmosphere. So the numerical model can tell you that, can give you a forecast that in 2 days there will be rain over Finland. But then the forecaster, it's very important to understand why this is happening. Otherwise, you cannot really control them. Otherwise, you're really depending on the numerical forecast. If you don't understand what are the dynamic mechanism behind. So conceptual models are really very, very important. If we forecaster want to give an added value to what we do. Otherwise, we are just machine. We can go home and numerical model can do everything. Okay, so let's go ahead. This is so just a comparison between on the left-hand side there is this day natural composite, satellite composite. Again, we are at on Wednesday or yesterday at 12 UTC, and on the right-hand side there is this NWP SAF cloud type product. So in the cloud type product, I think it's trying to understand what kind of there is the legend here, by the way, from the satellite data. Is trying to understand what kind of cloud is about. And I like very much this day natural image because I can see that there is a good match. Very nicely, the cloud type can identify this low-level cloud here. Yes, and we see, sorry, very nicely. You corrected me. It's not NWP, it's NWC. Yes, sorry for the mistyping error. And so you can see that there is this the model, the product says that there is a low cloud here in Central Europe, which you can also see very nicely here in the day natural picture. So this greenish color, it's a water cloud. Then what else nice other feature here? These are very thick clouds here connected to this frontal system, moving eastward over the British Islands. Then above over here, Finland and Scandinavia, some low cloud here. But of course, this is because the satellite is seeing the clouds from above, cannot tell how, if there is necessarily how low is the cloud below. So we have to use other things, other source of information. Thank you. I have still 10 minutes left. Okay, so let's go on. This is a radar picture I took yesterday from the Opera composite of radars. So now here we are investigating not only more the clouds, but the rain, this distribution of rain over Europe. It was taken it was a bit later, I think it was something like 6 UTC, so a bit later than the satellite image we have seen so far. But what to say that in this picture you can see that this spread rain area over which has now been further from the British island over the Western Europe. Of course, you cannot see from the radar image the low clouds because the radar doesn't usually, it doesn't detect clouds, but usually only rain. Clouds droplets are too small. And you can see here again some rain related to the frontal band over Eastern Europe. Yes, so I need to be a bit faster. So this is some surface weather, some synop weather information from yesterday at 12 UTC over Scandinavian, over southern Scandinavian and Baltic countries. And why this? Because it's connected to what I will show you later. So we can see that over Finland there is some mist, very wise also over northern in the north part of Baltic countries. There is some mist, and the temperature is quite high for this period, so it's above 0. And this is a nice picture I took yesterday at 12 UTC in Finland. So this is in Helsinki, and this is over the beach. So you see that the sea is covered by ice, which is a bit melting, but you can see that the weather condition are very, so there is really was quite dense mist, even fog, I could say. Again, here's some other synop information from Central Europe. We saw that if you remember, so in Central Europe, in Eastern Europe, between Central and Eastern Europe, there was this frontal band, and we can see some here some rain associated with it. Also some snow, maybe because here it's on the mountains. and again some synop from the western part of Europe. So again associated with this frontal system, very intense frontal system moving eastward. So very intense rain here, and also winds are very strong. So above 30 knots, 20, 30 knots. Okay, and this is finally the synop chart for the Deutsche Weather Institute yesterday at 12 UTC, and we can see a little bit so all the features that we've been so far investigating. So nicely you can see this frontal band over Eastern Europe, another frontal band there in the eastern southern part of the Mediterranean, and there's this very strong frontal system over British Island moving eastward to Central Europe, and this occlusion here, Scandinavian and the North Sea. So I think that I wanted to show you how we could start from the satellite picture, from the numerical models, a little bit to understand these conceptual models, and then at the end to get to the synoptic analysis. So again, I'm just sorry, I need to go a little bit into the future. Let's have a look into the future, what is happening. That's why I had this picture here. This is a picture of the infrared satellite picture from the infrared channel. And what I wanted to drive your attention to is this cloud here. So yes, somebody is showing me that the frontal system has moved eastward, and then there is this, but this is very interesting. So remember that in the very beginning we saw the jet streak in the very western part of the Atlantic, and you see this something here, some clouds, some wave developing here, and this is the forecast for European Center for tomorrow, today at 12 UTC and tomorrow 12 UTC, and you can see that there is this here frontal system developing here in the Atlantic, which will be later on tomorrow again affect the British Island and then move again eastward. So, but it was very nice to see the formation already of this system already in the infrared picture in the Atlantic, over the Atlantic. Okay, I have still a few minutes left. I would like to show you some nice picture of Helsinki. So Andreas was speaking earlier that what happens that when there is a heavy snowfall there, so the snow is accumulating over the roof. Okay, but then what happens when the weather is getting warm, or then it's raining? It's very dangerous, because then the snow can fall from the roof. So this is an image some teacher taken some days ago, a few days ago, yesterday, 2 days ago from Helsinki, and you can see that now the weather in Helsinki, it used to be very cold, and we had also some snow in the previous weeks, but then it has now got warmer, the weather, and you can see how the snow is melting, and because of now there is a danger that the snow is falling from the roof and then falling over people, pedestrians walking on the street. So you see that streets have been now, the pedestrian the lane have been closed because of the danger of snow and ice falling from the roofs. And also you can see here, this is a nice ice hockey field, which unfortunately now is being closed because it's too wet, and so people cannot skate over the ice. So this is the temperature in Helsinki from 1 week behind. So we had cold weather. It was even colder the day before the 5th February, it was below 10 degrees, minus 10 degrees. But now it has got very warm. So it seems now that the winter, it's a bit fighting with the warm weather coming. So we have had now very warm weather in these few last days. And this is how it looks like the situation in Helsinki for the upcoming days. So really not very encouraging. Maybe we are getting a bit into the winter, minus degrees here, but it's the temperature is oscillating between 0 and minus some degrees. So maybe at the very end, so in at the end of next week, maybe I can see here the signals from some warm air again coming back to Finland. Okay, time. So I think the time is. I have only 1 minute left, and this is a picture, a radar picture taken yesterday, Monday, at 7:15 local time in Sweden, so in Scandinavia. And I would like to ask you, do you know what are these trips due to? This is a radar picture. So here you have rain areas very nicely catched by the radar network. But what about this trip? Can you write in the text chat box about? Do you have any idea what are these? I know that this is weather briefing usually is mainly focused on satellite pictures, but nevertheless. So these strips are caused by the sun rising. No, they're not contrails. No, because usually this is the height of the radar beam is very low. It's pointing almost a little bit above the surface. They are not due to aircraft. Aircraft are much above in the troposphere, so the radar is pointing very. Of course, the radar beam is getting up with the distance, but it's very pointing almost over the surface. So these are due to the sunrise. So the radar beam is, you know how the radar works, is getting around, is sweeping around, and so when it comes to the direction of the sun, so the sun is all the time sending electromagnetic waves, so constantly. So that's why you can see these strips which are due to the sunrise, which is at a certain level, pointing to the radar when the radar is sweeping. Yes, cool. Thank you very much. So this is the last slide. Yes, never seen before. That's somebody. Maybe I think that this is more useful in the northern part of Europe because the sun it's very low in the winter. Thank you very much. Hope you have enjoyed. So we got to the end.